Hello everybody and welcome to another physics video. In this lesson we are going to start on projectile motion. Projectile motion is defined as the curved path that an object follows when thrown, launched, or otherwise projected near the surface of the Earth. There are two types of projectile motion: horizontal projectile motion and projectile motion at an angle. But in this video we are going to focus on horizontal projectile motion. Let's look at an example of horizontal projectile motion. The character Knuckles is at an elevated height and gets launched horizontally. Let's take a look at that one more time slowly. When we use the word launch, the object loses contact with the ground and follows a curved path in projectile motion. The path becomes curved as gravity takes effect of the object's y direction motion, while still maintaining the forward x velocity. The reason this is called horizontal projectile motion is because the object is launched along the x-axis or at 0 degrees. If it's aimed otherwise at any angle above or below the x-axis, it no longer is called horizontal projectile motion. Horizontal projectile motion needs to be observed as two different motions taking place at the same time. It is traveling across and falling vertically. When the object is launched horizontally, it has a horizontal velocity Vx, also called Vxi for initial horizontal velocity. However, there is no acceleration in the x direction, so Vx does not increase or decrease. For the y direction, it's dropping from a height, which means the initial y velocity is 0 meters per second. Once it leaves the edge of the ground, gravity begins to accelerate the object and gains velocity in the y direction. We can predict and describe an object undergoing horizontal projectile motion, but we'll need kinematics in both the x and y direction. These were kinematic equations when free fall was introduced. For horizontal projectile motion, the initial velocity will always be 0, and acceleration in the y direction is gravity. This is how our kinematics will be modified. Looks rather shorter and simpler. These were our kinematic equations for the horizontal direction. For horizontal projectile motion, there is no acceleration in the x direction, which means the x velocity stays constant. If that's the case, this is the only equation we need in the x direction. Let's move on to an example. Suppose you kick a rock horizontally off a bridge that is 321 meters high. The magnitude of the rock's horizontal displacement is 45.0 meters. Find the horizontal velocity at which the rock was kicked. The problem wants to calculate the horizontal velocity Vx, and this is the only equation that has Vx. However, we only know the horizontal displacement, delta x, but we're missing the time. We'll have to look at the y kinematics to solve for time. Something else the problem does give us is the height of the bridge. Since the rock is falling from this height due to gravity, it should be negative 321 meters as it is traveling downwards. Since height and gravity is known, time can be calculated using this kinematic. Through some calculations, time is 8.09 seconds. It is important to note that time is a shared variable in both the x and y kinematics. Since time is now known, the horizontal velocity can be solved. 45.0 equals to the horizontal velocity times 8.09. The horizontal velocity of the rock is positive 5.56 meters per second. When dealing with horizontal projectile motion, it is likely that two or more kinematics will be used. It is also very likely that you need to use kinematics in the x direction and y direction, but this only works if the time is known. This concludes the lesson on horizontal projectile motion. Hope you found it helpful.